Hey everyone, welcome back to the channel. Today we are diving into something that I'll admit used to intimidate me a lot when I started studying computer science. Big O notation. But don't worry, by the end of this video, you'll see it's not as scary as it seems. I've been there myself, so let's break it down step by step. So what is Big O notation and why does it matter? To put it simply, it's a way to measure how the performance of an algorithm changes as the size of the input grows. Think of it like this. Imagine you are packing for a trip. At first, you can pack everything quickly. But as you add more clothes, gadgets, books and snacks, it takes more time to figure out how to fit everything in your suitcase. That's kind of what Big O does for algorithms. It helps you understand how efficiently your packing process or algorithm scales as you add more stuff to it. Does it slow down a lot or can it handle more with ease? When I first encountered these terms O1, ON, ON square, it felt like learning a new language. But let's break down in simple terms. O1, it's like having a magic suitcase. No matter how many things you throw at it, it takes the same amount of time to pack. Imagine just snapping your fingers and boom, done. O1 algorithms are super fast and efficient. Now, ON, on the other hand, means that the time it takes to pack increases linearly with the number of items. If you add 5 more items, it takes 5 more seconds. Pretty straightforward. Then we have ON square, which is when things get a little tricky. Let me tell you, when I first realized how slow certain algorithms could be, I was stunned. I was like trying to pack every single item while repacking everything you have already packed over and over again. Frustrating, right? There was this time I was working on a project where I needed to search through a list of data points. Initially, I used a basic search algorithm without thinking much about its efficiency. The dataset was small at first and it was great work. But as the list grew, I noticed something. The process became excruciatingly slow. And guess what? I was using an ON square. Lessons learned. This experience taught me the importance of thinking ahead and choosing the right algorithm for the job. So what are some common Big O notations you'll see in practice? First, O1, constant time, like accessing an item in an array. ON, linear time, like searching through a list. O log n, logarithmic time, which is super efficient for large data set like binary search. ON square, quadratic time, which you want to avoid if possible because it scales poorly. And these are just a few examples, but understanding these basics can already make a huge difference when you're coding. At the end of the day, Big O notation is a tool that helps you think critically about how your code will perform, especially as your data grows. I found that that once you start thinking about algorithms, this way it becomes second nature. It's like knowing how to pack efficiently for that trip. And trust me, you don't want to be that person sitting on the suitcase trying to zip it shut. Thank you for sticking with me through this explanation of Big O. If you are a beginner, just remember that everyone struggles with this concept at first, and that's okay. It gets clearer the more you practice and use it. Let me know in the comment if you have any questions or if there's another topic that you'd like me to cover next. Don't forget to like, subscribe and hit the notification bell and you don't miss the future videos. So, see you next time.